This lesson is on linear inequalities. An inequality is two expressions put together with an inequality symbol. Linear implies a linear equation, so no other exponents on the variable other than 1. Solving an inequality involves finding all the possible values that can make the inequality true for the variable. These values are solutions, and they create a solution set for the inequality. Solving inequalities is just like solving equations, except for one thing. Let's think about if we had the inequality 2 less than 5. This is true because 2 is less than 5 on the number line. But what if we multiplied this inequality? Well, we could multiply it by 2 on both sides, and we get 4 is less than 10. Is this still true? Yes, this is. But what if we multiplied it by -1? Or, in fact, divided it by -1? Well, the signs would change, wouldn't they? You'd have -4 less than -10. Is this still true? Is -4 less than -10? No, it's not. So, therefore, if you multiply or divide an inequality by a negative number, the inequality sign must be reversed to make it true. Let's look at a few ways to represent the solution sets that we could have. First example here, 2x is greater than or equal to 6. This means that closed circle is used to represent the equal bit and anywhere forward. Now you can just go like that, or you can go like this and shade it in just to make it clearer. And that is the graphical representation of the solution, that x's have to be greater than or equal to 3 in order to satisfy this inequality. There's also set builder notation, where you write it so that you say x such that x's are greater than or equal to 3, or interval notation, which uses square brackets for including points, or round brackets for non-including points, and it goes left to right. So if you graph it, it's easy to do. The interval notation, you say 3 all the way to infinity, like so. Let's try the next one. This one says -x is greater than 1. Well, if we solve that, we'd have to multiply both sides by a negative, resulting in x comparing to -1, but the sign would change because we multiplied by a negative. So we'd have x is less than -1, not including, so we have an open circle at -1, and everything less than that is being shaded. So set builder notation would say x such that x's are less than -1. Interval notation would say everything from -infinity all the way up to -1, not including both points. Remember, infinity is always not including because you can't have a point at infinity. This one here is represented by x being greater than 5, not including because of the open circle. So same for set builder notation. And for interval notation, it starts at 5 and goes to infinity, not including 5, not including infinity. This one here shows us that we want to go all the way from -infinity to -4. So all of this stuff up to -4, and we are including -4, so we can put a closed circle. So this means that x's are less than or equal to -4. X's such that x's are less than or equal to -4. And that could be our equation. Our equation could be something else. Sorry, inequality could be something else. Next inequality here tells us x's are greater than or equal to x. Well, isn't this always true? Sure it is. So it's always true. So you shade the whole thing. So you say x's such that x's are in the real numbers. For interval notation, you say going from negative infinity all the way to infinity. Finally, you could have everything except for 1 point. So we want to say exclude the 3, but we want everything else included. So we could say that we want x not equal to 3. And for interval notation, you'd have to take the union of two sets, the two parts, saying negative infinity all the way to 3, both not including, union 3 up to infinity. A union represents both parts are included, and intersection would imply their common parts only. Here's some more examples of solving inequalities. So here, we solve it just like an equation, but if we run into a negative multiplication or division, we need to take that extra step. So 12 minus 2x less than 6x plus 1. Let's say we want to subtract 6x from both sides. We'll have negative 8x, and the 12 and the 1 are still there. So now let's say we subtract 12. We get negative 8x is less than negative 11. Now when we divide by negative 8, at that same time we need to switch that sign. We've got x greater than 11/8. So if we want to represent this solution, it would be on a graph as 11/8, not including, and everything greater than. For interval notation, you would say 11/8 to infinity. Or set builder notation, x is such that x's are greater than 11/8. Those are the 3 ways of representing your solution set. Let's try a more complicated example. This one involves fractions. Remember, in the past, we have been multiplying through by the lowest common denominator to get rid of any fractions. Sure, you could multiply this out, but then you'd have all these fractions to deal with, and we don't really want to be dealing with them right now. So let's multiply through by the common denominator, which is 12. We've got 12 times 12 times 12, because 3 and 4 both go into 12 nicely. Remember to multiply all components. So when we simplify, 12 over 3 is 4, 12 over 4 is 3, the rest has to stay. So we've got 8x, because we're multiplying by 4, plus 20 minus 12 times 6, which is 72, greater than or equal to negative 3 bracket 12x minus 8. So we can multiply this out, giving us negative 36x plus 24. And this side's all the same, but let's just put these numbers together. 20 minus 72, giving us negative 52. Now we can start to get our x's together. Let's add 36x. So we've got 44x minus 52 greater than or equal to 24. Add the 52. You've got 44x greater than or equal to 76. And you've got division by 44 giving us x's are greater than 19/11, which was, 76 over 44, which simplifies to 19/11 because it has some common factors. So again, we can graph this out and say x's are greater than or equal to 19/11. And don't worry about scale here. The point is to make sure you know where that point is and which side is being shaded. You could also say everywhere from 19/11 to infinity, including 19/11, or set notation simply like so. You could also have simultaneous inequalities. This means that you have two parts. This inequality actually means that 1 minus 3x is greater than or equal to 2, and 1 minus 3x is less than 5. So you could solve those two equations and find the combined part of that, but you can also just solve the entire thing together. So as long as you do the same thing to all three parts, you're doing the exact same thing as before. The goal is to isolate x so that you have an equation such as x is between two numbers. So then you'll know that x is between those two numbers on the number line because x is bigger than the lower part, and x is less than the greater part. So what do we do to get x by itself? Well, first we want to subtract 1 from all three parts, giving us 1 less than or equal to negative 3x less than 4. Now we would have to divide everything by negative 3, which means when we divide by a negative, we need to switch the signs. So we'll have negative 1/3 greater than or equal to x greater than negative 4/3. You'll notice that this makes sense because negative 4/3 is actually the lower part on the number line, and that's with an open circle. And the higher part on the number line is the negative 1/3. So we want to rearrange this. So we've got negative 4/3 is less than or equal to x, and x is less than or equal to negative 1/3. Now this implies that x is between negative 4/3, not including negative 4/3, and the maximum is negative 1/3. So we've taken the intersection of these two components, these two inequalities, to form just the middle ground of what is available with both of them, both of the requirements. So interval notation would say from negative 4/3 up to negative 1/3, including negative 1/3, not including negative 4/3. In terms of set builder notation, we have x such that x is, and you can just write exactly what you had, x is between negative 4/3 and negative 1/3. Let's try this other example. It'll work very similarly. So here we'll multiply everything by 4 first because we're trying to get it at x to be alone. So we've got negative 4, 2x plus 5, 12. And then we can subtract the 5 from all three sides. So if we subtract 5 from all three sides, we get negative 9 less than 2x less than or equal to 7. And divide everything by 2. So we've got negative 9/2 less than x less than or equal to 7/2. Now this number is smaller than this one, so that makes sense. On a number line, we've got negative 9/2. X's are bigger than all of those, and x's are less than the 7/2. So you'll notice, same scenario, it's between those two amounts. Again, interval notation can also be written similarly, and so can set builder notation. You could also be asked to write an inequality for a statement and solve it. So let's try the following. Double a number increased by 1 is between 2 and 8. The word between is going to imply the simultaneous equations. So double a number increased by 1 is between 2 and 8. It didn't say between or equal to 2 and 8. It said between 2 and 8, so we're going to assume it doesn't include 2 and 8. Now, let's solve. Subtract 1 from all three sides. You get 1 less than 2x less than 7, which gives us X is between 1/2 and 7/2. So you could answer X is between 1/2 and 7/2, or you could use set builder notation or interval notation as used before. Let's try to translate the next one. If 5 is subtracted from a number, x minus 5, then the result is at least 7. So if it's at least 7, it has to be greater than or equal to 7. So to solve that, you add 5. So then you get x is greater than or equal to 12. You could also be given an application example. Let's look at the following. After a serious automobile accident, most insurance companies will replace the damaged car with a new one if the repair exceeds 80% of the Blue Book value of the car. John's car had $9,200 worth of damage, but was not replaced. What can be said about the Blue Book value of his car? We don't know the Blue Book value, so let's call that x. Taking 80% of the Blue Book value would be 80% of x. The company will replace the damaged car if the repair cost exceeds this amount. So if the repair cost, $9,200, was greater than or equal to 80% of the Blue Book value, then it would be replaced. But it was not replaced, meaning we need to change this to less than. So $9,200 was less than 80% of the Blue Book value, meaning they had to repair his car instead of replacing it. So if we solve that, that would tell us division by 0.8 would give us 9,200 divided by 0.8 is 11,500. So that tells us that his car, the Blue Book value of his car, is greater than $11,500.